Okay, previous video we talked about how we got this triangle for normal faulting. Talked about each of the three sides. And now we move on to a similar conversation for reverse faulting, and the approach is pretty similar. You already know from reverse faulting what's S1. S1 is SH max. It will be greater than SH mean, and the least principal stress for reverse faulting is SV. So from the first part, meaning SH being greater than SH max, what do you have there? That you have to be above, right? It's pretty much similar to this, which I discussed previously. Because this line is a 45-degree line, so for SH max to be greater than SH mean, you're going to have to be above that line. Because on that line, SH max equals SH mean. So that's how you get this part. Can we get anything from this? SH mean is greater than SV. Well, you can already see that because SV doesn't change, right? Remains here. But SH mean lies to the right of that, right? SH mean lies to the right of that. And that's precisely this actually. You see that? Because this line is SV. So from this second half, you get this vertical line. So you're only left with the top. And I'm going to use green for that. So we're only trying to get this. This is the last part left for the triangle. And that is going to come again from CFF, Coulomb's frictional faulting theory. And we can walk through the math again real quick. If sigma 1, what's sigma 1 is SH max, of course, minus pore pressure, divided by what's sigma 3, SV, right? SV minus pore pressure has to be less than or equal to, right? Less than or equal to 3.1. And let's quickly do that math. SH minus pore pressure is less than or equal to 3.1 SV minus 3.1 pore pressure. And take pore pressure to the other side, minus 2.1 pore pressure. And that's your, it's less than or equal to, so that's your upper bound, right? So we calculate this value, it gives us that green line, and we're saying SH max, which is the vertical line here, has to be less than or equal to, that's your upper bound right there, and that's how you get that triangle. And of course, to get the strike slip faulting stuff, you just connect this point to this point and you're done. So that's how you get the Zubakugram. And you can actually also walk through this kind of derivation, CFF, for strike slip, and you get that blue line. So you will always be here, always be above. That will come from the SH max being greater than SV greater than S mean. That's what you're going to have for strike slip, and that will give you this and this vertical lines. And that's how you get the stress polygon or Zubakugram. And you can see it's telling you all those stresses you're looking for, your SH max has to fall within this polygon. So we establish bounds on it, and later we'll talk about adding more constraints to further reduce the size of this polygon, meaning to further bracket the range of uncertainty in the SH max. And that's pretty much what the story is. So for a given depth, pore pressure, and mu, right? Mu was 0.6. That's how we're able to get this 3.1, right? But you can always substitute whatever mu is to get the updated value for this. We want to know the possible ranges of principal stresses. That's what we get from the stress polygon. Given a depth, that will give us the vertical stress, right? The overburden. Given the pore pressure, we'll be able to take that out of the total stresses. Given me, we're able to get 3.1. What are the ranges? What are the possible ranges of the principal stresses? And that's how we came up with all those brackets, those constraints on the range of the principal stress, the other principal stresses. As we already know, we're just looking for ranges for SH and SH mean. This is a fact, right? And that's why we have to be above the degree 45 degree line. And I explained that. That's why we have to be above this. That's why we have to be above this. Good. And now we want to see the effect of pore pressure on the failure line. And remember, this is effective normal stress. This is just shear stress because fluids don't support any shear stress. So this is precisely the total stress in whatever direction it is, S1, S3, minus pore pressure. So if we start out with pore pressure being hydrostatic and it's 30 megapascals, then given this line plotted with slope of 0.6, it has to go through the intercept. That's all you need to define a straight line. We can draw then at 3 kilometers depth, we can calculate SV, right? And take out 30 from SV, you get sigma V, and that was 39 for this problem. So once you know this point, of course, you can draw a circle that starts from that point and touches this line, and that will give you S1 or sigma 1, right, at hydrostatic pore pressure. So that's how you got this circle. And then you increase pore pressure to 40 megapascal. It used to be 30. So a 10 megapascal increase. And what does that do? That will reduce your sigma V, right, which is SV minus pore pressure by 10, right? It used to be 39, so it becomes 29. Then draw the circle that will just touch that same line, and that's purely geometric. And you can do that using the mathematical equation. And now you get this. So you get your new least principal stress for whatever faulting regime it is, your new sigma 3. And what's happening to the circles? They are moving to the right, they are getting smaller. You increase pore pressure again by another 10 megapascal. So the circles are getting smaller and they're moving to the left. And that is saying that the bounds are getting tighter. That's actually what you see here. And that will mean you're getting a more narrow range for the stress polygon. So you're able to bracket it within a smaller range of uncertainty. So more circle gets smaller and shifts to the left at higher pore pressure values. At high pressure, at high pore pressures, it takes a smaller difference between S1 and S3 to cause failure. And that difference is precisely the diameter of those circles, right? The diameter is getting smaller. It means that the maximum allowable stress, the maximum allowable stress, right? And, it means that it takes a smaller difference between S1 and S3 to cause failure. That's what I was saying. And the last point, which is what I was jumping into, is that S1 is the maximum allowable stress, right? S3 is the minimum allowable stress. And those were what defined the upper and lower limits on the circle, right? But you take out pore pressure from them. And those will change depending on the faulting regime you are in.